In this video, we are presented with a nice algebra problem, and we are required to find the smallest value for a and b and evaluate the numerical answer to this equation here simplified, or this expression. So we are given that the square root of a be multiplied by the square root of a plus b plus the square root of b is equal to 3 times root b, open bracket, root a plus 5 root b. So how can we actually approach this? Now, one smart way to look at it is that, seeing that we would multiply root a times whatever is in the bracket and root b times whatever in the bracket, we could actually try and solve for root ab. So that is what I'm going to do here. So let me rewrite this as root a times root a plus root b is equal to 3 root b root a plus 5 root b. And I'm going to distribute, and I'm going to use the distributive law and distribute my root a and my 3 root b here. So now we would be left with a plus root a b, two roots being multiplied would basically bring to under the square root sign. This would be 3 root a b, and I'm going to write the a before the b, and this would be simply 15b. The square roots would cancel. Okay, great. So now that we are at this point, what we could actually do is to get the a and b on one side and get the root ab on the other side, seeing that we're actually trying to make that the subject. So a minus 15b is equal to 2 root ab. So this is where I'm going to leave it. Why? Because we actually have a 2 root ab here in the equation, and we could actually just substitute a minus 15b there in the equation. So I'm going to do just that and see. So I'm going to actually rewrite the equation that was given. So it was given as 3a plus 2 root ab plus 2b all over a plus root ab minus b. All right, so let's do our substitutions. So that would be 3a plus, let me use a bracket, a minus 15b plus b, and this is all over a plus, let me divide by 2 because this is root a, this is not being multiplied by 2. I could have actually just multiplied throughout by 2, but let me just do it this way. So this is a minus 15b over 2 minus b. All right, so let's simplify. Let's see what we would get. So we know that the b would be removed from here and the a's would add. So on the top, we would be left with 4a minus 14, wait, this is actually 2b. So this is 13. So 13b over, now 2 would be distributed throughout, so we would have 2a. So 2a plus a minus 15b minus 2b over 2. And once again, we have a fraction on the denominator. Well, let's simplify. So this would be left with 4a. I'm going to simplify first, and then I'm going to actually carry out the operation. And this would be 3a minus 17b over 2. So the numerator would be multiplied by the 2 in this instance. And this would be 8a minus 26b over 3a minus 17b. Now this would be our answer simplified, but the question did not just ask us to simplify the equation. It had asked us to actually find the smallest possible values for a and b, which would make this equation true. So what I'm going to do is I'm going to actually rewrite the original equation, and the only way to actually do this is by trial and error. So root a times, and we're going to actually prove if these are our correct answers. Now, if we look at this original equation, we would see that root a, or a would actually have to be the bigger term in this instance, seeing that root b is being multiplied by 5 root b here and 3 root b. So a would definitely have to be the bigger term in this instance. So that is a b. All right, so let's use trial and error to actually solve. And what we're looking for a and b are perfect square numbers. So that would include 1, 4, 9, 16, 25, and so on, 36. All right, so looking at this, we would need to see that the a would have to be far greater than the b. So if we should use, let's say for example, if we should use 36 and 4, well, 4 would be b, 36 would be a. So that would be 6 times 6 plus 2, and this is 8, 48. So 48 on this side, and over here we would have 3 times 2, which is 6, times a is 6. Well, root a is 6 plus 5 times 2 is 10, so 16. And this is definitely not correct. This is 96. So we see that it is not possible for 36 and 4 to be a possibility. So let's try 25 and 1. So if a should be 25, that would now yield 5, because square root of 25 is 5, being multiplied by 5 plus 1. Square root of 1 is 1. So this is 30, and this should be equal to 3 times 1. So 3 times 1 being multiplied by 5 plus 5. So this is 10. So indeed 30 is equal to 30. So our valid solutions for a and b are 1 and 25. So a is equal to 25 and b is equal to 1. But we are not through as yet, because the question had asked us to evaluate this right here. So seeing that a is 25, so that is 8 times 25 minus 26, and b is 1. This is all over 3 times 25 minus 17 times 1. So this is now 174 over 3 times 25, 75, minus 17, that is 58, and this is equal to 3. So the answer for this is 3. So now let's validate the final answer at the top. Now, seeing that we know that a is, let's validate this answer. So a is 25, b is 1. So 75 plus root 25, so that is 10 plus 2, and this is over 25 plus 5, 29. So this is 87 over 29, and this is indeed 3. So definitely a is 25 and b is 1. And that would be the solution to our problem. So if you enjoy videos like this, be sure to leave a like and a comment down below. Thank you for watching. See you in the next video.